right, hello everyone, welcome to Math 40. Today we're going to begin on page 3 of lecture notes week 3. We left off on the unit circle, and depending on whether you're in my morning or afternoon class, we either had the trig functions for angles that terminate in quadrant 1 and 2, or possibly even 3. If you have already seen how to find the sine and cosine, or I should say cosine and sine, coordinate points for 210, 225, and 240. Feel free to fast forward the video. I am, however, going to be showing you how to find it using or by reflecting the points. I know that in my morning section, we found these by drawing the 30, 60, 90 and 45, 45, 90 triangles, but I'm going to be discussing an alternative way, which is a little bit quicker for finding those coordinates. Okay, so starting with 210, if I want to find what the x and y coordinates are of this point, which is on the terminal side of 210, what we have to remember is that the x coordinate is described by cosine of the angle, and y is described by sine of the angle. And so we could do a triangle, as I mentioned earlier, but it's a little quicker if we just go ahead and reflect over the point that corresponds to 210. So what I mean by that is if I were to use the x-axis as a mirror and take this point on the terminal side of 150, it would reflect over to the point on the terminal side of 210. And so these two would mirror each other. And I'm going to go ahead and erase these lines so that it doesn't become too overwhelming with all of the bits and pieces of this diagram. But if we reflect it over, what does that mean? What do they share in common? Well, in order to get to that point, we have to travel a certain distance in the x direction. And that distance is the same both for the point on the terminal side of 150 and the point on the terminal side of 210. So that means that they share in common this x value, right? This negative radical 3 over 2. So that's going to be a common x value that they share. The y value, however, it's still the same distance from the x-axis up until this point as it is from the x-axis down into the point at 210, except that we're going in the negative y direction. So instead of having a positive 1/2, we're going to have a negative 1/2 for that point. Okay, now let's consider 225. Which point in quadrant number 2 reflects over to 225? Well, that would be the point on the terminal side of 135, right? If I go ahead and draw this vertical line, and I see that those reflect over, which means that when we are trying to get to either one of those points, we're going to travel the same x-axis, so they're going to share the x in common. So that means that for 225, it's going to have an x value, an x coordinate of negative radical 2 over 2. But then for the y coordinate, we're going to have, instead of a positive radical 2 over 2, it's going to be a negative radical 2 over 2. And then finally for 240, the point that reflects from the second quadrant down into this point on the third quadrant would be the one corresponding to 120. So it would have the same x value of negative 1/2 and a negative y value, so negative radical 3 over 2. Okay, we're going to repeat the process in quadrant number 4. And now we're going to be using the points in quadrant 1 to reflect over. So starting with 330, that one is a reflection of angle 30, the point that is on the terminal side of angle 30. So that means that we're traveling the same amount in the x-axis. So it's gonna have the same x coordinate, square root of 3 over 2, but then a negative y coordinate, so negative 1/2. For 315, the point that reflects down would be this square root of 2 over 2 comma square root of 2 over 2. So same x coordinate, because we're traveling the same amount in the x direction, but then it's going to have a negative y coordinate. So negative radical 2 over 2. And finally, we have this point at 300, which is being reflected by the point at 60. So we're going to have same x, 1/2, but negative y coordinate. So negative radical 3 over 2. Okay, now what does this mean? What do these points mean? Well, we can now use the unit circle to help us find the sine, cosine, tangent, secant, cosecant, cotangent of any angle here on the unit circle simply by looking at the points. For instance, if we wanted to find what is cosine of 240, I would go over to the 240 degree angle, I would look at its coordinates, and if I want to find cosine, I would pick out the x coordinates. Then I'd be able to say that cosine of 240 is negative 1/2. And what if we want to find what is tangent of, let's say, 90 degrees? Well, tangent is a little bit trickier because remember in the coordinates, this is cosine, this is sine. But remember from the definition number 2, tangent is y over x. So we actually can still use the coordinates to help us find out what is tangent. So if I want to find tangent of 90, that would be the y, which is 1 at 90 degrees, over x, which is 0. And 1 over 0 is undefined, which means that tangent of 90 degrees is undefined. Okay, so it's a very useful tool. Unit circle is a very useful tool for finding any of these angles, as well as any angle that is coterminal to the angles on the unit circle. Okay, so let's take a look at some examples then. They want us to use a unit circle to find each of the following, starting with sine of 120. So let's see, if we go over to unit circle, here is 120. Sine is represented by the y value. So we're going to get that sine of 120 is square root of 3 over 2. Sine of 120 is square root of 3 over 2. This is for part A. Okay. What about secant of 30? Well, for secant of 30, we don't have secant explicitly in the coordinates. That means that we're going to have to think about what it was according to definition number 2. Well, secant is reciprocal of cosine, and cosine, if you remember, was x over r. So secant would be r over x, right? It's going to be r over x, but on the unit circle, the r is a 1, so we're going to get a 1 over x. So we have to take a look at what is the x coordinate at angle 30. So at angle 30, here's angle 30. Here is the x, square root of 3 over 2. This is for cosine, but secant is the reciprocal, so we're going to get 2 over square root of 3. So you can either write it already as a 2 over square root of 3 and then rationalize, or if you want to go through this process where you write 1 over square root of 3 over 2, you can. It's just working a little bit longer, but we can do it that way since we've already gone down this route. So we're going to have a 1 times a 2 over radical 3, because dividing by a fraction is the same thing as multiplying by reciprocal. And then this becomes 2 over radical 3. We want to make sure that we rationalize. So I'm going to multiply top and bottom by a square root of 3. Let me just bring down the 2 radical 3. And so we get 2 square root of 3 over 3. All right, and then finally for part C, we have tangent of 315 degrees. Now remember, tangent is y over x according to the second definition. So we're going to be looking at 315, which is this angle. Look at the coordinates at that point. We have square root of 2 over 2 for x, negative square root of 2 over 2 for y. So we're going to bring those values back. Okay, so for y we said it was negative square root of 2 over 2, and then for x it was positive square root of 2 over 2. Now we could say, well, this number in the numerator and this number in the denominator are the same, so they're going to divide out to 1. Or if you want to go through the process of actually multiplying by the reciprocal, you'll get the same answer. I like to already just kind of cancel out here because they're both the same number and it divides out to 1, but I can't forget about that negative, so I need to make sure to bring it over. Okay, so we get a negative 1. That is a lot easier and a lot faster than having to draw right triangles or having to find the reference angle of an obtuse angle to find these trig functions. Okay, so the unit circle is actually very convenient. Okay. Example number 3. Find all of the values theta in the interval 0 to 360. Let me talk a little bit about this notation before I continue. Here we see bracket and parenthesis. These bracket and parenthesis mean the same thing that they did in Math 130 or Math 140 or even Math 110. In algebra, we saw that a bracket means it includes this endpoint, and the parenthesis means that it excludes the endpoint. Okay, so we're saying in the interval from 0 to 360, including the 0, excluding the 360, find all of the values such that cosine theta is equal to negative square root of 2 over 2. Okay, so now they're giving us the value, and we need to find which angle corresponds with that trig function value. So let's stop and think about it for a little bit. I mean, we could just simply flip through and see which check point by point, which one has a cosine of negative radical 2 over 2. But we don't have to go through every single point if we know what we're doing. This is asking, remember, cosine theta is supposed to be x. This is asking what has an x value, which by the way is cosine theta, that is equal to a negative radical 2 over 2. So if x is a negative number, we can think in which quadrants is x negative? Well, x is negative in quadrants number 2 and quadrant number 3. Okay, so I'll just write that as a comment. Okay, so notice x is negative, so x is less than 0 in quadrant number 2 and quadrant number 3. Hence, we will focus on the angles there. That cuts down the number of points that we have to consider by half if we're only considering the left hand of the xy plane. So let's see. Could we cut it down even further? Well, if it's radical 2 over 2, we can think about which reference angle has radical 2 over 2 associated to it. Well, those are usually 45, 45, 90, right? So we can focus on those angles that have a reference angle of 45 degrees. But in any case, it's enough to focus just on quadrant 2 and quadrant 3. So in quadrant number 2, the angle that has an x value of negative radical 2 over 2 is 135. So that would be one angle. Okay, so one possibility is 135. The other possibility, and we continue going down through the points. The other possibility is here, at 225. So we have negative radical 2 over 2 for an x value at 225. Just so we can see what I was talking about regarding the reference angle on here, for 135, okay, this is the terminal side. Okay, that's the terminal side. And then the reference angle would be this one here. Well, if this is 135 degrees, the reference angle has to be 45 degrees. So that's what I was mentioning earlier. Look for the angles that have reference angle 45. That's going to give you a cosine of negative radical 2 over 2 in quadrants 2 and 3. Same thing with quadrant 3. If I now focus on this 225 that we got as an answer, this is now the reference angle, this here, and that's also 45 degrees, because in order to get from half the cycle, 180 to 225, we have to add 45 more. All right. That's how you can work with those problems. Let's try one more. Actually, a couple more. Find all the values of theta in the interval 0 to 360 such that cosecant theta is negative 2. Okay, so again, we don't have cosecant explicitly as part of the coordinates. We only have cosine and sine, which means that we have to change this into something that is part of the coordinates. Cosecant is a reciprocal of sine. So if cosecant is of angle theta is negative 2, then sine of angle theta has to be negative 1/2, because it's simply the reciprocal. So we have to find an angle that has a sine theta of negative 1/2. And if you recall, sine is always the y value. Now if y is negative 1/2, we have to think about where is y negative, in which quadrant, so that we don't have to go through and visit every single point. So notice that y is going to be negative in quadrant 3 and quadrant 4. Because all of the points in quadrant 3 and quadrant 4, we have to go down below the x-axis to reach them. So that means that they have a negative y value. So we're going to be focusing on angles that are in those two quadrants, in quadrant 3 and quadrant 4. So let's go over to unit circle. Here are quadrant 3 and quadrant 4. And let me actually look at the value one more time. We're looking for all those points that have a y coordinate of negative 1/2. So let's take a look. Well, starting here at 210, we've already found one point. This has a y value of negative 1/2. What's another one? Let's see. So we get to 330, right? 330 has a y value of negative 1/2. And that makes sense because it's reflecting right over from 210 across the y-axis. So that means that they're going to have the same distance from the x-axis, or negative 1/2. So our two angles are 210 and 330 then. I actually forgot to highlight my answers for the previous example, so let me do that. Okay. All right. The example number 5, find all of the values in the interval 0 to 360 such that cotangent of theta is negative 1. Again, we don't have cotangent, but we do, we could use the second definition. So I'm just going to write here, recall that cotangent of theta is x over y. And so that means that we want cotangent to be -1. That means that we want -1 to equal x over y. I'm simply replacing cotangent with that value because that's what it's equal to. And if we multiply both sides by y here, what happens? Well, these are going to cancel out because this is like a y over 1. And then the y times a -1 was just going to become -y. We're going to get -y is equal to x. So we're looking for all of these angles where this is true, where -y equals x. Okay, we are looking for points where x and y have the same value, and I'll say same absolute value, but opposite sign. And what does that mean? Well, that means, like, for example, if if y is 3, then x is -3. If y is -5, then negative times -5 would give us +5, so that x is +5. So they're going to have the same absolute value, but opposite sign. Now, what quadrants have opposite signs for x and y? Well, let's take a look. Go to unit circle. If I look at quadrant 1, I have positive x and positive y. So this one gets disqualified. If I go to the second quadrant, I have -x, positive y. So this is actually a good quadrant to look in. And then what else do I want to be true about x and y? They need to be the same absolute value, so the same value, but opposite sign. And the only point that satisfies that is this 135, right? These have the same value, but opposite sign. So one of the angles is 135. Where else do we have opposite sign x and y? If we go to quadrant 3, that means I have -x and -y, so those have the same sign. That quadrant gets disqualified. And then we can go to quadrant number 4, which would have a positive x, -y. So this one also, this we can look at to see if there are any xy values that have same value but opposite sign. And that's going to happen for 315. Right here we have the same value, but this one's positive, this one's negative. So 315 would be the other angle. Right. Now for these 3 examples, example 3, 4, and 5, you can always check your work and see that it's correct by plugging these angles back into the original equation and making sure they satisfy what's given here. So I'm actually going to show you how to do it quickly on the calculator just so that we don't spend too much time on it. Okay, so what I'm going to do here is cotangent. If my calculator doesn't have a key for cotangent, and most calculators don't have a key for cotangent, so what I'm going to do is I'm going to type 1 over tangent, because I know that cotangent is reciprocal of tan. Okay. And it's 1 over tangent of the first angle that I'll check is 135 degrees. Now remember, there are 2 types of units of measurement that you can be working in. You could be working in radians, or you can be working in degrees. So to make sure that you're working in degrees, go to find the mode button on your calculator, and when you hit it, it should give you these two options of radian or degree. Now, depending on your calculator, it's going to look a little different. If you're working on a scientific calculator, yours might actually display at the top an R, which means you're working in radians, or a D, which means you're working in degrees. Okay, so just make sure that you're working in degrees. And then we're going to check what is 1 over tangent of 135. And we get -1, so that works. Let's try now 1 over tangent of 315, because we want to check our second answer. That also gives us -1, so that looks good. Let's check example number 4. For example number 4, we have cosecant, and that's 1 over sine. I want to check 210, so 210. That gives me -2, so that looks good. And then 1 over sine of 330, and that also gives me -2. And then finally, the last one, we're checking cosine. Cosine of 135 is this -0.707. It's supposed to be negative radical 2 over 2, but my calculator doesn't return it as a fraction, it returns it as a decimal. So what I could do to verify that it's the same number is calculate what is negative radical 2 over 2. And we see that they are the same number, so that means that it's correct. And let's try now cosine of 225. Okay, again, we get the same thing as negative radical 2 over 2, so that means that we have the correct answer for that as well. If you're ever in doubt whether or not you found the correct angles, you can always plug into your calculator the result and see if it agrees with the equation. Let's go to example number 6. For example number 6, they're asking us to use a unit circle to find each of the following, starting with sine of 720. So in order to find sine of 720, 720 is not on the unit circle. On the unit circle, we have 0 to 360. So we have to find what is 720 coterminal to. Okay, so let me just write that as a comment. So to find sine of 720 using the unit circle, we must find what angle is 720 coterminal to, and then we have to make sure that that angle is in the range of 0 to 360. So let me actually rewrite this. Let me write what angle in the range 0 to 360 is 720 coterminal to. That's what we're going to do next. Okay. I'm going to get 720 and figure out how many complete cycles are part of 720. And well, actually 720 is a result of taking 2 times 360 and then adding no more degrees, right? Because it's exactly 2 cycles. So that means that 720 is coterminal to 0 degrees. Those two are coterminal. What that means is that sine of 720 degrees is the same thing as sine of 0 degrees. Now at this point, we can go and look at the unit circle. Here is 0 degrees when the angle doesn't open at all. I'm trying to find sine, which is the y coordinate, so that would be 0. So this is 0. What about cosine of 1800? Well, again, 1800 is not on the unit circle, so that means that we're going to have to find what is 1800 coterminal to. So let's see, 1800 degrees. I want to find out how many full cycles are in 1800. So I'm going to take 1800. I don't know if you guys can see. I think that's a little bit better. Okay. 1800 divided by 360. It's giving me exactly 5. So that means that we have 5 times 360 plus 0 degrees. So again, just like what we got in the previous example, 1800 is going to be coterminal to 0 degrees. And so cosine of 1800 degrees will be equal to cosine of 0 degrees. Now, what is cosine of 0 degrees? Again, let's bring out the unit circle. This is 0 degrees. Cosine is the x coordinate, so that's a value of 1. And last one, tangent of negative 450. We want to find out what is negative 450 coterminal to, and we want to make sure that it is in the range 0 to 360, meaning we want to make sure we pick a positive angle. Okay. So let's see, how would we want to accomplish that? And so the way that we can do that is by saying, this is like almost completing 2 cycles, but in the negative direction. So negative 2 times 360, that would be negative 720. But we don't actually complete the second cycle because we're stopped short. To see how much we are stopped short by, well, we can rely on our calculator to help us. So if I take negative 720 and I've only completed 450 degrees out of those negative 720, I get 270. And actually, don't be deceived by this negative 270. It's just the way I entered it into the calculator. But just so that you are convinced, let me go ahead and punch this expression into the calculator on the right-hand side, and you'll see that it gives us the negative 450. So if I take negative 2 times 360 and I add to it this 270, I'm going to get that negative 450. Okay, so what does this mean? This means that negative 450 is coterminal to 270. And so we can find out what is tangent of negative 450. Tangent of negative 450 will be tangent of 270, which remember is the same thing as y over x at the 270 degree angle. So here's 270, y is negative 1, x is 0. So we're going to get negative 1 over 0, which is going to give us undefined.